Hi friends, welcome back to my channel. Now you are watching Education to All. Still, if you are not subscribed to my channel, please subscribe, and if you like the video, please support and share to your friends. Let us start to the topic. Today I am going to start real numbers, which is very important and basic topic. It's the first topic of CBSE 10th standard. So let us discuss about this real numbers. In real numbers, we need to know what are the types of numbers we have. First, so we have natural numbers. So natural numbers are the numbers which are used to count. So we can able to count numbers like 1, 2, 3 and so on. So the numbers which are starts with 1, 2, 3 and so on, we can say the natural numbers and indicate the natural numbers with the capital N. So the capital N, the set of natural numbers we write as, so 1 comma 2 comma 3 and so on. So the minimum number means least number is 1 and it's continuously going on. So the greatest number we cannot find in a natural numbers. Second type of numbers, whole numbers. So whole numbers are the numbers including the natural numbers and one more extra, that is what extra? 0. So 0 comma 1, 2, 3 and so on numbers. So if you observe clearly 1, 2, 3 and 4 and so on, we can say the natural numbers, but 0 is not contained in natural numbers, that is extra we have. So the whole numbers indicated with the capital W. So the set of whole numbers is equal to 0, 1, 2, 3 and so on. Next whole numbers are integers. So here integers are indicated with either Z or capital I. So it's very simple. Integers are which having negative numbers and 0 and positive numbers. So these set of numbers we can write. So some numbers, minimum numbers we have many and so on, like -3, -2, -1, 0 and then 1, 2, 3 and so on. So we should identify one small hint here. In integers, there is no smallest number, there is no biggest number. Why? Because the negative numbers, if I write continuously, we cannot find which is the smallest number. And if I write the positive numbers and continuously, we cannot find the greatest number as well. But one thing we can conclude, the 0 is the middle number. So 0 is the middle number of integers. 0 left side, if I go continuously, it will be negative. 0 right side, if I go, it's continuously the positive numbers. And the fourth one, rational numbers. So very simple logic. Rational numbers we studied in earlier stages of different classes. So rational numbers are the numbers which can be expressed as a p by q form, where q not be equal to 0. So irrational numbers in the form of p by q. Here there is a condition, q must be not equal to 0. Why, sir? Very simple logic. If q equal to 0, what happen? Very simple, sir. For example, 2 by 3, it's a fraction I can say, but 2 by 0 if I write, it is not defined. That's why the numbers which are in the form of p by q, where q not equal to 0, all the numbers are called as rational numbers. P by q, any number if I can able to write. So for example, I write 1 by 2, 3 by 4, I can able to write 5 by 7, anything I can write. So that's okay. Can I say 1 is a rational number and 2 is a rational number? Otherwise, -5 is a rational number and 0 is also a rational number? Yes, definitely. Why? Because so we can write 1 as the fraction 1 by 1 p by q, where p is equal to 1 and q is also 1. I can write like 2 by 2, same, and I also write like 10 by 10, everything shows as 1. So definitely p having q having p by q. It means that 1, 2, 5, anything is rational numbers, all natural numbers are rational. Similarly, -5 I able to write like rational or not. For example, minus 10 divided by 2. 2 table cancel, minus 5 times. So minus 5 I can able to express as P by Q, where P is equal to minus 10, Q is equal to 2. Definitely. So absolutely right. Similarly, 0 is a rational number or not? Yes. So we can write 0 by 3. So numerator is 0, denominator any number, it will be always answer is 0. So we can conclude that 0 is also a rational number. From this we can conclude all natural numbers are rational numbers, all whole numbers also rational, the negative numbers. So all integers also rational numbers. What is meant by irrational? It's very simple. A rational numbers now P by Q form. Irrational numbers now opposite to that. So numbers which are not in the form of P by Q, we cannot express in the form of P by Q. It's called as irrational numbers. So simple example, root 2. Root 2 we cannot express as a P by Q form. Irrational numbers are root 2, root 3 and root 4 can I write as irrational numbers? Absolutely not. Why? Because the 4 I can write as root 2 whole square, the square root and the root power 2 will be eliminated, so we will get it as 2. So root 4 is 2, 2 is a rational number again. So that's why in a square root any perfect square is having, so that will becomes a rational, it's not a irrational number. So we can say that root 9 also not a irrational number, and similarly root 100 is not, and root 121 is also not. So why? Because 9 is a perfect square, 4 is a perfect square, 121 also perfect square. So similarly all perfect squares which are under root, square root only, remember square root only, these are not irrational numbers. But what is irrational number? So a number which cannot be expressed as a P by Q form. So I'll apply the relation between the natural numbers, whole, integers, rational and irrational numbers with all together what we call. So first natural numbers, next whole numbers, and then it is called integers. Integers are indicated with two symbols, one is Z and I. So we can indicate with Z or I. So rational numbers are indicated with the Q, and irrational numbers, so there is no relation between the rational and irrational numbers. So I'll represent irrational number as Q dash. So these are all called family of the numbers. Who is the family head? We can say real numbers. So one thing should identify here, all natural numbers, so from in to out and out to in, all natural numbers are whole numbers, all whole numbers are integers, all integers are rational, all rationals are not irrational. It will not be. So there is no relation between irrational and rational. So that absolutely not have any relation. Now, if you come into out, all is possible. Next, if I come from out to in, so out to in, all rationals are integers, all integers are wrong. That's absolutely wrong. So sum is possible. I can say that some rational numbers are integers, some integers are whole, some wholes are natural. Okay, and there is no relation between whether come from out to in or into out. There is no relation between these all together and irrational. Irrational number is absolutely different than the other numbers, other conditions. So this is the family of the numbers. Who is the family head? Real numbers. So the all real numbers is called together as complex numbers. Complex numbers. So real head complex. Let us start topic Euclid division lemma. First of all, what is lemma? Lemma is a proven statement which is used to prove another's. So here lemma means already proven statement that will be used to prove a particular statement. So look into the one statement. For every positive integer a, there exist b and q's which satisfy a is equal to bq plus r, and where r have a relation 0 less than or equal to r less than b. This already we know, but we have to look with some basic example. So let us discuss So 2 divides 7. How many times? Very simple. 3 times it is divides. 2 3s are 6. So we will get it as 1. We know division algorithm. So the basic of division algorithm is what? So dividend is equal to divisor into quotient plus remainder. That's all. 7 I can able to write as 2 3s are 6. 2 into 3 plus 1. So this is the value. So A explained Euclid in the condition Euclid division lemma as division algorithm. 7 is equal to 2 3s plus 1. So by comparing that, A is equal to B cube plus R. A is equal to 7, B is equal to 2, Q is equal to 3 and R is equal to 1. Where R is called remainder, A is called dividend, B is called divisor and Q is called quotient. I will explain Euclid division lemma with a small example briefly. Find the HCF of 20, 25 by using Euclid division lemma. So basically Euclid division lemma are used to find HCF. So what is the procedure should follow? Given condition is 20 and 25. So first of all we should decide which number is less or which number is greater. 20 is less than the 25. So we have to write the greatest number. 25 is equal to, with the 20 how many times it is divided? So 20 one time divided. What is the remainder? So remainder will be 5. So we can check it. 25 divided by 20. So we'll let one time. So 20 and remainder is 5. So then we write like this 20 again we have to take it. This 20 should take it as, and then we should divide with 5, the remainder. So 5 table cancel how many times? 4 times plus 0. 0 is the remainder. So we can cross check here. 20 and the 5 table cancel 4 times, 20 exactly, and the remainder is 0. So when the remainder you got 0, we have to stop the procedure. So if you stop here the procedure, then what is the HCF? So which divisor will be gives the 0 as a remainder, that is called HCF. So HCF is equal to 5 for the 20 and 25. So HCF is 5. So this is a method to use Euclid division lemma to find the HCF of any particular two numbers and to get the better clarity. So find the HCF of 455, 42 by using Euclid division lemma. First step should identify which number is greater. So 42 is less when compared to 455. So greater number should write 455 is equal to. So 42 into how many times exactly cancel? So we'll check it. 455 with the 42. So normal division 10 times if I multiply, 420 times. So here remainder is 5 and 3. 35 is remainder. So 42 into 10 times plus 35 is a remainder. So next step, this 42 should write it as a dividend. 42 is equal to. So which is the divisor? 35 will becomes the divisor. So 35. How many times exactly? So if I consider 135 are 35, 235 are 70. So 70 is greater number. So I have to prefer one time. So plus. In 42, 35 eliminated now, 7 is a remainder. Next, this 35 should write as a dividend. So 35 and this is called divisor. 7 how many times in 35? Exactly 5 times. So 5 multiply. So how many, what is the remainder now? So what is the remainder? In 5 7s are 35, 0 is the remainder. So we have to stop the Euclid division lemma applying. So when remainder is 0, which is divisor will gives the remainder is 0, that is called HCF. So HCF is equal to 7 for the 455 and 42. Next topic is fundamental theorem of arithmetic. What is meant by fundamental theorem of arithmetic? Very simple. Every composite number can be expressed as product of primes, that factorization should be unique. So prime numbers are numbers. The numbers which have only two factors are called prime numbers. Simple example, 2 is a starting prime number. What are the factors of 2? 1 and 2 only. So 2 is called prime number. Next, 3 is a prime number. So 1 and 3 itself. Next, 5 is also prime number, 1 and 5. So like that, a numbers which have only two factors comes under prime numbers. So another name, composite numbers. we have to learn about composite also. So based on factors we can decide. So one is prime factors and another is composite numbers. So prime numbers means a numbers which have only two factors. So composite numbers means a numbers having more than two factors. More than two factors. So example 4 is a composite number. How many factors have 4? So 1 is a factor, 2 is a factor and 4 is also a factor. It having minimum 3 factors, so it comes under composite number. So come back to the fundamental theorem of arithmetic. Every number can be write as product of primes. For example, I can check that 34. So how can I express 34 as a product? So 34 I can write like prime factorization 2 table 17 times. So other than that we cannot write any other way. So we can write 34 is equal to 2 into 17. 2 17s are 34 only. So we cannot write 2 17s or 35 or 36 any other number. So the product we need to write express as a primes. That factorization is unique. Unique means 2 17s are 34 only. That is unique. We cannot write another any number. So let us look into another. For example 10. 10 can be written as 5 table 2 times. So 10 can be written as 2 into 5. 2 power 1, 5 power 1. 2 is a prime number and 5 is also prime number. Remember, prime factor is not always we have to write with the prime numbers. Now the last topic. So rational numbers and their decimal expansion. The decimal expansion will be divided into 3 categories. One is terminating, non-terminating and recurring or repeating, and the third one is non-terminating. So terminating means very simple. So any number which ending, for example 2 by 5. So 2 by 5, how the decimal expansion will be ended? So 20 means 4 times cancel. So this is called terminating decimal expansion. Second one, non-terminating and recurring. So non-terminating, it will not be terminated but it is repeated. So simple example 1 by 3. 1 by 3 decimal expansion 0. So this will becomes 10 and 0.333 and 4. So it will never stop. This is called non-terminating, means it is not stops and as well as it repeats. So this is called non-terminating decimal expansion and repeats. So third one is non-terminating. So this simple example. So root 3 is 1.732 and continuously it will go on. It will not terminate and it will never repeat as well. So the non-terminating decimal expansion we will expect for irrational numbers. Then what about terminating and non-terminating recurring decimal expansions? Now this is for rational numbers. Q, here also rational numbers. So terminating numbers can be expressed as P by Q form. Non-terminating and recurring decimal expansions also we can write as a rational numbers. But non-terminating decimal expansion we cannot write it as in the form of P by Q. Simple example of these conditions are like root 2, root 3, root 5, root 7. All these conditions comes under non-terminating decimal expansions. So without doing the actual division, we can also conclude whether it's a terminating or non-terminating recurring or non-terminating. How to decide? It's very simple logic. So let me explain clearly. If any denominator, so for example is 2 divided by 10. So we can write 2 divided by 2 power 1 into 5 power 1. So the 10 can be expressed as 2 5s are 10. Okay. So we can observe that 2 by 10 value is how much? It's very simple, 0.2. Definitely it is terminates. And one more example. So 5 by 2, it is also 2.5. One time exactly and decimal. So 1 point remaining 20 means 4 times 20. So 1.4. Now we should identify 2 by 10, 0.2, 5 by 2, 2.5, 7 by 5, 1.4. Every time the decimal expansion will be stops somewhere. then the logic is the any denominator is in the form of 2 power n or 5 power m, otherwise both including 2 power n into 5 power m. So denominators are these formats are existed, definitely that will be terminating decimal expansion. So the simple example you identify 2 by 10, 10 contain 2 and 5, third condition 2 and 5, m and n values will be anywhere, any integer. So here 2 and 5 decimal is stops somewhere, and only 2 having, that is also stops, only 5 having, that is also stops somewhere. If other than these all expansions of the denominator you observe, means that will be non-terminating recurrent decimals, either it is non-terminating decimal expansions. So how to decide these both? If the given number is in the format of root numbers like root 2, root 3, root 5, all irrational numbers, that we can say that it is non-terminating decimal expansion. If the numbers other than the denominators like 2 power n, 5 power n, 2 power n or 5 power m are both included, so but it doesn't contain any root values, it will becomes non-terminating and recurring. Simple example, we write like 9 by 7. This is also, observe that there is no value like 2 power n or 5 power n, so we can say that non-terminating and recurring. And 1 by 3 contain a denominator in the form of either 2 power n or 5 power m, both not. So that's why it comes under the second category. What is second category? Non-terminating and recurring decimal expansion. Okay, that's all for today. I hope you all have understood my concept clearly. If you like the video, please subscribe and share to your friends and support my channel. Thank you everyone.